From here, Earth looks like a paradise floating in the void. But beneath this serene beauty, just beyond the atmosphere, chaos brews, a graveyard no one talks about, spinning silently around our planet, space, the vast, mysterious frontier that stretches beyond our world. It's where we launch satellites, explore the unknown, and expand our horizons. But, as we venture farther into space, we've created an invisible problem. It's a chaotic, invisible graveyard of human-made debris orbiting Earth at unimaginable speeds. This isn't just trash, it's a ticking time bomb, a problem that threatens the very future of space exploration. That problem is space debris. Space debris, also known as space junk, refers to any non-functional human-made object left in Earth's orbit. This includes defunct satellites, spent rocket stages, fragments from past collisions, and even tiny particles of paint. While these objects might seem insignificant on their own, together they pose a serious risk to the safety of satellites, spacecraft, and astronauts. Space debris comprises thousands of pieces that range in size, from specks of paint to large, inactive satellites. As of recent estimates, over 36,000 objects larger than 10 centimeters are tracked today. But millions of smaller fragments, too tiny to monitor, orbit silently, each piece capable of catastrophic damage. At speeds of up to 28,000 kilometers per hour, even a small piece of debris can cause catastrophic damage if it collides with a satellite or spacecraft. Imagine a grain of sand moving at that speed. It could puncture the body of a satellite or even damage the International Space Station. This risk is escalating, with the number of objects in orbit increasing year by year. These events turned thousands of functioning objects into lethal shrapnel, spreading chaos through low Earth orbit. But why should we care about these fragments? The debris jeopardizes satellites that power our modern lives. From GPS navigation to weather forecasting, television broadcasts to emergency services. Everything depends on these fragile networks, and this graveyard threatens to bring them all crashing down. Space debris isn't just a nuisance, it's a major safety hazard. With each satellite launch, more objects are added to Earth's orbit, compounding the risk. Collisions can create even more debris, leading to a vicious cycle known as the Kessler Syndrome, named after NASA scientist Donald J. Kessler. The Kessler Syndrome suggests that the more debris there is in orbit, the greater the chances of a catastrophic collision. These collisions can result in thousands of smaller debris pieces, making certain orbits increasingly dangerous and potentially unusable. This poses a threat not only to satellites and spacecraft, but also to human life in space. Imagine a world where astronauts are grounded, satellites can no longer function, and humanity is trapped on Earth. Our ambitions shattered by the very technology that once launched us to the stars. While the world focuses on challenges closer to home, this silent crisis remains in the shadows. Space debris lacks the immediate visibility of other global issues. It's invisible, distant, and easy to ignore. But its consequences are anything but remote. So, what can we do about this growing problem? There are several potential solutions, but they all come with their own set of challenges. Active debris removal. ADR involves sending spacecraft into orbit to capture and deorbit large pieces of space debris. This method uses robotic arms, nets, or harpoons to physically grab and pull the debris into Earth's atmosphere, where it burns up upon re-entry. Several space agencies, including ESA and JAXA, are developing ADR technologies, but these missions are expensive and technically challenging. Another innovative approach involves using ground-based lasers to push small debris out of orbit. These lasers don't destroy the debris, but instead, they change its velocity slightly. causing it to slowly fall towards Earth. However, this method is still in its early stages and faces significant limitations in terms of precision and energy requirements. Space tugs are another promising idea. These spacecraft would use thrusters or robotic arms to latch onto large pieces of debris and guide them to a safe, lower orbit where they can burn up. Space tugs could work alongside ADR missions, helping to clear more debris in one go. International regulation focuses on creating and enforcing global policies to reduce space debris. Satellite operators must adopt end-of-life disposal plans, like moving defunct satellites to graveyard orbits or ensuring controlled re-entry. These measures prevent further accumulation of debris and protect active missions. Global cooperation ensures sustainable and responsible use of space for future generations. Recycling space debris involves harvesting materials from defunct satellites and other objects in orbit. These materials can be repurposed for in-space construction, such as building new satellites or repairing existing ones. This approach reduces waste and promotes sustainable use of space resources. Humanity isn't sitting idly by. Around the world, scientists and engineers are racing to clean up the graveyard. From harpoon-equipped satellites to massive nets, innovative solutions aim to remove debris piece by piece. Yet these solutions face immense challenges. Cleaning space isn't just expensive, it's politically complex. Who's responsible for cleaning up debris? The nations that created it? Or a global coalition? As nations debate responsibility, private companies are stepping in. SpaceX, Amazon, and others are exploring self-regulating systems to deorbit their satellites once their missions end. But is it enough? While removing existing debris is crucial, prevention is key. There are steps we can take to ensure that new debris isn't created. These actions collectively help maintain a cleaner, safer orbital environment. Satellites should be equipped with systems like propulsion units, drag sails, or other mechanisms to ensure controlled deorbiting at the end of their operational life. These technologies help burn up satellites safely in Earth's atmosphere, preventing them from turning into debris. Designing for safe deorbiting ensures minimal long-term impact on orbital environments. It also aligns with global sustainability goals for space exploration. Fragmentation from satellite collisions or explosions is a major source of space debris. To prevent this, satellites and spacecraft should be designed to withstand internal malfunctions, and intentional satellite destruction in orbit should be avoided. Regular maintenance and monitoring can help mitigate risks of fragmentation. These measures ensure that existing satellites don't become hazardous debris. Global organizations like the Interagency Space Debris Coordination Committee, IADC, provide comprehensive guidelines for responsible satellite operations. These include measures for proper disposal, collision avoidance, and long-term debris management. Governments and private operators must follow these standards to ensure a safer orbital environment. Collaboration on such policies helps build a sustainable framework for all space activities. Active technologies like robotic arms, nets, harpoons, and tethers can capture and remove large debris from critical orbits. These systems are crucial for cleaning up existing debris that poses a collision risk to active satellites. Continuous advancements in these technologies can make debris removal more efficient and scalable. Active mitigation ensures safer and more sustainable space operations for future missions. Launch vehicles and rocket stages left in orbit often contribute to space debris. To address this, operators should ensure all leftover hardware is deorbited safely or moved to less congested areas like graveyard orbits. Designing reusable rockets and minimizing discarded components also reduces waste in orbit. Sustainable launch practices are key to maintaining a clean and functional space environment. We can also improve the durability of our satellites by adding protective shields to prevent damage from smaller debris. Additionally, international cooperation and regulations, such as those being developed by the United Nations, will be essential in creating guidelines for responsible space exploration. Space has always been humanity's final frontier, a realm of infinite possibilities. But our path to the stars is fragile, threatened by the debris of our past ambitions. If we don't act now, this graveyard could become a prison, confining us to Earth indefinitely. The invisible graveyard above us isn't just a technical problem, it's a question of survival, ambition, and responsibility. It's a test of whether humanity can rise above its mistakes and preserve its future in space. The stakes couldn't be higher. Every day the graveyard grows, inching closer to the tipping point. But there is hope. Engineers and scientists are working on cutting-edge solutions, from laser-based debris clearing to AI-powered systems that predict and prevent collisions. These innovations require global collaboration. The United Nations Office for Outer Space Affairs is pushing for new treaties and shared technologies, emphasizing that this is a problem humanity must face together. What if we succeed? A future without orbital chaos unlocks limitless possibilities. Space hotels, asteroid mining, and interplanetary travel. The same ingenuity that created this problem can forge solutions that redefine humanity's destiny. This is the promise of a collaborative effort to protect our orbital highways and ensure the stars remain within reach. The invisible chaos above our planet is growing, but there's still time to act, to clean the graveyard, prevent catastrophe, and keep humanity's path to the stars open. The question is, will we rise to the challenge before it's too late? Thank you for watching. Stay tuned, stay curious, and keep exploring. Don't forget to subscribe, like, comment, and share. This is XI Space.